All right, so let's get started with this first topic by looking at an example of a quadratic equation or a quadratic function. I'm going to say function because we're interested in graphing it, and we're also going to be looking at x and y variables, but a quadratic function that is written in factored form. So take a look at this example that I have here. It is y equals x plus 1 times x minus 3. And as opposed to our original examples of quadratic functions, this one looks a little bit different because we don't actually see an x squared. But just in case you're a little concerned that this doesn't count as a quadratic, let's FOIL it out. So that means take the x and multiply it to both, and take the 1 and multiply it to both, and then x. So we're multiplying everybody. This is FOIL, or double distribution. And we get x times x is x squared. Well, I should write y equals x times x, the first one is x squared. X times negative 3 is minus 3x. 1 times x is plus 1x, or just x. And 1 times negative 3 is minus 3. Now, as we saw in the last section, we get two x terms that can be combined. They're like terms. So we'll get y equals x squared, and this negative 3x and positive x become negative 2x when we put them together, minus 3. So this equation, the one that we started with, is the same as this, what we call the standard form. This is the factored form, and this is the standard form. The standard form looks like a quadratic, but isn't especially helpful for us when we're trying to graph. And you'll understand that in a moment a little bit better than right now. So even though this equation looks very nice and quadratic-y, if I can make up my own word, it's not especially helpful to us. But as it turns out, the factored form is very useful. So let's rewrite it down here and find out why. So again, y equals x plus 1 and x minus 3. When we were working with quadratics in factored form in the last section, we talked about how if we wanted to know when this equation equals 0, so if we made this 0, we can figure it out fairly easily because we use the zero product rule, which says that if I have two quantities that are being multiplied, this quantity times this quantity, and we know that the answer is 0, then I can say that it's safe to assume either this first term is 0, and that's why it equals 0, 0 times whatever, or the second term is 0. It's the only way that we can multiply and get a 0. So that's what we called the zero product rule. And we said that it was helpful in finding out when a factored quadratic equals 0. Well, let's think about how that might be helpful in the graphing scenario. Let's say if it's pretty easy to find out what would make this equation 0. We just have to say, okay, what would make x plus 1 0? Well, that would be if x was negative 1. If I plugged in negative 1 here, it would become 0. And it's pretty easy to find out what would make the second part 0 when x is 3, because 3 minus 3 is 0. What that means is that this graph, we don't know what it looks like, we just know it's a parabola, is going to have a value of y equals 0. In other words, it's going to be somewhere on this level. This is when x is equal, or y is equal to 0. This is like the horizon line. It's going to equal 0 at x equals negative 1. That's right here. So right here it's going to be 0. And when x equals positive 3. 1, 2, 3. And these are what we call zeros of the function, because it's where the quadratic hits the horizon line, or the x-axis. It intersects with the x-axis at that point. And again, why? Well, we only know that because we know that it's going to have a y value of 0, which happens here. It's the only way to get the equation to equal 0 is if x is -1 and x is -3. So we know, in a sense, we are figuring out a little bit of what this parabola looks like. Either it has to look like this, meaning it's an up and down parabola, or a U-shaped parabola that intersects at those 2 points, or it has to look like this, because it's always going to go through the 2 points. It's going to be symmetric, and we know that it has to go through the intercept of -1 and 3. So the question is, which one is it? Is it U-shaped or is it upside down U-shaped? Well, remember that we talked about in the previous section that in order to have an upside down U, the number out front of the x squared would have to be negative. And so we asked the question, is it negative now? And it's not. It's positive. So if it's positive, it must be a typical parabola, and it's going to look roughly like this. So that's what we call using the zeros of a function to find its graph. That's all there is to it. Now, if I wanted to be more specific, like if I wanted to find out more things about this graph, I could maybe say, okay, well, I know that these 2 points are centered, they're symmetric around an axis of symmetry. So I could say, well, maybe what's in between? 1, 2, 1, 2. So the middle of this parabola happens right here. So maybe I could try to find out, like, okay, well, where is the vertex? Well, it must be at 1. What happens if I plug in 1? 1 plus 1 is 2. And 1 minus 3 is -2. So 2 times -2 is -4. So I actually could say 1, 2, 3, 4. That this equation actually looks like this. We could try to find out where the graph intersects the y-axis. I don't know if you remember from our original, we talked about how y-intercepts, intersections with the y-axis, we can figure out by just plugging in 0. So I could figure out that pretty easily too. Y equals 0 plus 1 times 0 minus 3. That's 1 times -3, or at -3. So we can actually find out quite a bit about this graph using our factored form. This original, the standard form, it doesn't really mean anything to us. But the factored form, we just found out 4 valuable pieces of information just by looking at it. One is the zeros, where it hits 0. By the way, those are also called the x-intercepts, right? We found the vertex, and we found the y-intercept. All of those were easy to find using the factored form of the equation. So let me just find, just to finish this off, let's make this nice and dark. We found our 2 no, not y-intercepts, our 2 x-intercepts. We found our vertex, and we found our 1 y-intercept. And with that, we get a pretty clear idea of what this graph is supposed to look like.